Good afternoon. Good afternoon. I'm Jay Lemery. I'm a roundtable member. Just to update you, for those keeping track, I'm no longer at Cornell. I moved to the University of Colorado 2 months ago. As you can tell from her accent, our next speaker comes from the Gulf region, which I think is an important perspective, having someone from there on extreme weather, toxins, and as well as responsible resource use. Dr. Denise Reed is a chief scientist for the Water Institute of the Gulf. She's a nationally and internationally recognized expert in coastal marsh sustainability and the role of human activities in modifying coastal systems. Dr. Reed has been extensively involved in sustainable restoration planning in coastal Louisiana as well as the California Bay Delta. She served on numerous National Research Council committees and is currently a member of the Chief of Engineers Environmental Advisory Board and the Ecosystem Sciences and Management Working Group of the NOAA Science Advisory Board. She has received degrees in BA and PhD from the University of Cambridge. Please welcome Dr. Reed.
Thank you, Jay. I was thinking just now that perhaps we should have kept the information on dinner until after the talk, and so people really had to stay. Thank you very much for sticking it out today, I'm hoping that I can provide a little bit of insight to take you off into your discussions this evening. I apologize that I'm not going to be able to join you. I think, you know, if I could have a facetious title for my talk, it would be Beyond Conventional Wisdom. I'm going to talk a little bit in a bit of detail, and I'm so glad there was some chemistry in one of the presentations earlier today, because I do realize I had quite a lot of graphs in here, none of which are mine. But I'm going to talk about this ecosystem service. We heard a lot this morning about ecosystem services in general, and one that came up a number of times was this idea of coastal protection. This idea that natural systems can protect coastal communities. So I'm going to delve into that a little bit from my Louisiana perspective, but also from a more general perspective about what we know. I'm not by any means a health specialist at all, but I am going to try and relate the story that I'm going to tell you towards coastal communities. I've lived in coastal Louisiana for 25 years, and I live way down the bayou perhaps I'll point on one of the slides to about where I live if I have a map of Louisiana, but it's, I think my perspectives on that are really derived, perhaps not from my science, but from my personal perspectives. So I cast this in the light of coastal change, and I think that one of the things that's very important to communicate to anybody about coastal issues and coastal systems and the value of them is that they are very dynamic places. That they change not just because of the things that we have done to them, and I think perhaps a lot of the context for the discussion at the moment is about the different kinds of ways that we have in the past massively modified natural systems. Obviously Manhattan here, this is the seawall at Galveston. This is a very old picture that I took probably in the late 1980s, and of course there's been a number of major storms in that area since then. Coastal port facilities in coastal Louisiana and ongoing kind of activities. This isn't just something that we did back in the 1700s and the 1800s. It's very much something that is an ongoing and developing issue as people rush to the coasts, and I'm sure you know the statistics better than I. Importantly, though, there are some nice places left. There is some natural system left, perhaps some of it in isolated places like Alaska that have less population pressure, but also there are some really quite dynamic and important and productive ecosystem components left within the coasts of the United States, the lower 48. And I think it's those that we learn from. And it's the contrast, I think, between the natural systems that we have left and those that we have massively altered that helps us think about where across that spectrum we actually think that we should land for the future, recognizing that we're not going to take many of those things on the left side of those slides out. Coastal Louisiana is perhaps a poster child for many of these changing conditions. I'm not going to spend a lot of time about them on the background to some of the problems that we have, but we've had a couple of fairly major high-profile issues within the last decade down there. Obviously Hurricane Katrina, obviously the 2010 oil spill. But we do have a coast which was already severely degraded and that was undergoing a very rapid change. We had lost from land to open water, that means marshes and barrier islands changing to open water, over 1,800 square miles of land changed to open water since the 1930s. It's really quite a dramatic amount when you think that, I know this is in square miles, not in kilometers, but when you think that across many parts of the US, if you think about the state that you live in, if you live on the coast, then you think about coastal land loss or you think about coastal restoration, people are probably going to describe it in acres. We're going to describe it in square miles in Louisiana, and that's a factor of 640 for those of you who only work in metric these days. So we have an ongoing land loss problem in Louisiana, and so I think that provides a very interesting context for this idea of change. One of the things that we constantly try to communicate to coastal communities, anybody who's interested in the coast, is that it is going to change. Ours is changing too rapidly in the wrong direction, but these are not systems that we can kind of pickle and put in a jar and preserve always in the same place. As we think about ecosystem services, as we think about the things that coastal systems provide to us that we value and that we want to have in the future, we have to appreciate that there is going to be a dynamism there, and that dynamism has to be, that dynamic has to be factored into our considerations. This is the future. Those statistics on the last slide, this is our current impression of the future for coastal Louisiana. Just a little bit of geography. I don't have too many map slides in here. The Mississippi River here is the mouth of the Mississippi River. The city of New Orleans up here, Lake Pontchartrain, state of Mississippi, state of Texas over here, the mouth of the Atchafalaya River. The red on here is what our recent analysis has showed us that we will lose in the next 50 years without any increase in over and above the current investment in coastal restoration activities. But my presentation today is not really about coastal land loss. It's about this ecosystem service concept, about how coastal habitats can actually provide, or can they provide, protection to communities. One of the things we did in our recent master plan in Louisiana was not just look at what happens to the wetlands and barrier islands, but also what happens to storms and floods as they move across that landscape. And so this is the same geography you see here. And so these are the future flood depths. I'm sorry, these colors don't show up very well. But this is the depth of flooding associated with a 100-year storm, again, 50 years into the future. And so I can tell you that the darkest red color over here is 20 to 25 feet, and I'll have to move around away from the microphone here. But the palest shade of yellow is 0 to 5 feet. And so this is the storm that has a 1% chance of happening every year. And you can see that basically the whole of coastal Louisiana is in the floodplain 50 years into the future. And some of it is in very, very deep floodplain. And so that clearly has implications for the people that live out here across the communities. And the black dots on here represent communities. They're all towns with viable populations that have schools, that have stores, that have gas stations, that have people living in them, scattered across the coast here, subject to that flooding in the future. So what would happen if perhaps we could reverse those land loss trends? If we could do something about the red on the first map, would it actually help us with the reds and the yellows on the second map? Could we actually make some kind of difference? Well, our analysis in the master plan, and again, I'm not going to spend a lot of time going into this. So this is the curve that I just showed you. Basically, the amount of land over here and time over here. This is that decay into the future. The red map over 50 years. We did identify in the planning process that if we spent $25 billion, on the best set of projects we could devise, we could actually stop the land loss, not get back any of it that we'd already lost, but we could stop the land loss, not fix it in place, but build more in somewhere else. It would still lose here, but we would build more in another place, a kind of a equilibrium situation, if you like. So what would that actually do for the flooding, for those coastal communities? What would that mean for those coastal communities? And I think that so there are a number of perspectives to this. We spent quite a lot of time earlier today talking about fisheries and about fisheries production, and clearly we have a very successful and active inshore fishery in Louisiana, as well as the importance of the Gulf Coast fishery, which you're probably aware of from the BP oil spill a few years ago. But there's also both the culture of those communities that live in those black dots scattered across the coast. And I think what we call in the National Coastal Assessment, in the National Climate Assessment coastal chapter, what we call lifelines for those coastal communities, the infrastructure that supports them, the roads, the power lines, the small grid stations that you see here that are essential to actually supporting life out there on the coast, and in the context of the conversation today, therefore an essential contribution to the health of those individuals who live out there. Well, what does the science tell us? That's kind of the fun, that's why I'm here, I guess. What does the science say? What do we really know about this? Well, and I'm not going to go through the details of many of these graphs in any detail at all. We actually know quite a lot to support this general concept that wetlands do actually change the way water flows through them. And so whether we're looking at how high the grass is, whether it's short or tall, whether it's flexible or stiff or those kinds of things, people have done experiments in both of these actually are flume studies, in controlled laboratory experiments where you bring the grass in, move the water through it, and we actually know something about that. We know quite a lot about that. But when we take that, and I know you can't read the words on this slide, that's not the purpose, but when you actually take that information and try to translate it in an operational sense towards what you would actually do in a landscape for a community to make a difference to them, then you have to think about it in a slightly different way. This is a study that was done by the Corps of Engineers, wave dissipation wave dissipation by vegetation. And one of the things that I want you to kind of look at across here is really the structure of this. And what it recognizes is that there is a difference among different kinds of plant communities, and we'll get into that in a little bit in a moment. It does actually matter whether you have marshes or mangroves out there, or whether you have SAVs. Well, that might not really get you too much of an effect. But what really matters is that a lot of the science, the kind of really controlled experiments that we can do, of the kind that perhaps I showed you the data from just now, look at these individual properties of the plants in a very individual sense, look at how they flex, how they move, how many leaves they've got, those kinds of things. But what we really need when we think about the coast is we really need to think about their community properties, how they move together, and really what their dynamics is in terms of these large spatial and temporal extents. And so what you find, and actually one of the things that's quite reassuring about looking at a slide like this, is that there is something in every one of the boxes. There is some kind of information about that. But when we actually really start to probe into that, we have to ask the question about how do we operationalize the information, and is it of the type of rigor that we would need to actually move that out on the ground. And I think that part of this broader discussion that you're having about ecosystem services is really about how we operationalize that concept as a whole, how we actually take this idea of ecosystem services, which we can all relate to very directly, as we heard the presentations this morning about all the different things that happen out there, how we can take that information and use it in real decision making by individuals or by governments or by whoever is making that decision to make a difference for people on the ground. These kind of conversations are happen, as you know, after every one of those events, and even after Sandy, the same kind of conversation that we have after Isaac, and I'll talk a little bit about Isaac in a moment. The idea, everybody knows that if we have more wetlands, that will slow the surge down. Everybody knows that. I heard that again after Sandy. But how much will it slow the surge down? That's the thing. We can calculate, and it can be decimals of centimeters. Is that really what you want to communicate to people? Okay, so let's look at that in a bit more detail. There have been a few studies of this recently, and I'm just going to try to summarize a little bit of kind of what we do know. This is actually a very interesting paper that just came out. I think this is probably an 11 paper at this time, plus one, where a team from TNC or from Santa Cruz did a meta-analysis of the protective role of coastal marshes. And again, it does actually support this idea very, very well, looking at a number of different studies, that as far as wave attenuation is concerned, there is a relationship that stands up over a number of studies from a number of different places between the amount of percent wave attenuation. That's how high is the wave at the beginning of the vegetation, and how much does that wave height decrease as the wave moves into the vegetation. There's a relationship between wave attenuation here and how much of the particular marsh that you have there. They also look at the factors influencing shoreline stabilization, looking at a number of different studies from a number of different places, and they also recognize that issues about elevation are very important, as there are issues about hydroperiod. It's a very interesting study. I'm not going to go into the details over here, but if you want to look at it in more detail, you can look at it. What about storm surges? That's what tends to dominate the public discourse anyway, in many instances. This is a study that was done by some folks at the Corps of Engineers. It's a numerical modeling study. And this is one way. What I was saying earlier was how we as scientists can do these very controlled experiments within laboratory flumes and things like that, where we put a few pieces of vegetation in and we can flow water through it in a very, very controlled manner. Well, the way we can zoom that out to the landscape effect is by using numerical models. And so what happens in this study is that the team put in a particular piece of marsh into a model grid. They said, okay, we've got this square of marsh in here. What does that square of marsh do in the model to the storm surge as we move the storm surge over the piece of grass? And it was just a square. And what they found was that two things were really important. One was the elevation of that marsh. Was it a high marsh or was it a low marsh? Was that piece of land very high in the intertidal, or was it very low in the intertidal? And the other thing that was important was how high was the storm surge? Was it a big storm surge or was it a small storm surge? And basically what you see on this diagram are two axes. This is where the marsh is quite high, and this is where the marsh gradually gets lower, across from left to right. And then from the top to the bottom, you have an increase in surge height. And what do the colors mean? The red colors, the red and yellows and oranges in here, mean that the piece of marsh in the modeling grid actually really reduced the storm surge. And what you see is that as the marsh gets lower, that effect gets less. But most importantly, as the storm surge gets higher, that effect is essentially eliminated. And so what this tells us is this kind of analysis can start to point us towards where and when can this kind of protective ecosystem service be most effective. The most important message that you get out of this is it's not going to be the same everywhere, and it's not always going to be the same at that place, because it's going to be different from different types of storms. Another aspect of this variability from one place to another has been much better explored in mangroves. We heard earlier about mangroves and how important they are as substrates for different kinds of bacterial growth. There's been a lot of attention to this because of the massive mangrove plantations in Southeast Asia. Again, a lot more stimulated too after the tsunami a few years ago. Actually several tsunamis. And so what we've got on all of these graphs, and they're all taken from different studies, is basically on the vertical axis, it's some measure, and slightly different measures in slightly different studies, but the vertical axis is always this idea of the amount of reduction in the wave height, and then along the horizontal axis is the depth of the water here. It's this depth effect that we saw on the previous graph. And so in general, what you see in these different studies is there is one relationship with mangrove in this one and another relationship without mangrove. And so this tells you that mangroves are making a difference in terms of the amount of attenuation in there. But what you also see across these different diagrams is what species of mangrove you have might make a difference, and that depends upon the architecture of the tree, the shapes of the leaves, how bendy they are, those kinds of things. Another one up here, with and without mangroves. You also notice that in different studies done in different places, in different kinds of physical locations, that these relationships can be different directions. And in this one down here, this is a particularly interesting one, where they tracked over time. They tracked different plantations of trees that had been planted at different times, and so they could see how the relationship changed with the age of the tree. So what this tells us when we look at the science of these kinds of things is, well, we actually know quite a lot about mangroves and wave attenuation, but what it tells us is that it's not very easy to operationalize. It tells us in some places there can be a very important, very strong, very tight effect, and in others it can be much more variable. Here's another example, I think, of this is actually a modeling study using a wave model called SWAN, which has been adapted for use in mangrove systems by Suzuki and a number of students. And so again, this is some measure of wave, this is the wave height over here, and this is distance into the mangrove forest. And this is actually for cyclone waves, much bigger waves than some of those other field studies were for. One of the challenges of this is actually measuring what happens during a storm. Is quite difficult. And so one of the things that we're very often doing is we're taking relationships that we understand from those laboratory studies we do in the tank with the water, or from the field studies that we do on relatively windy days, but not in major hurricanes or cyclones. We have to take that information and try to extrapolate this to the more extreme conditions. And this is an example of that. So this is using cyclone waves, but it's a modeling study. And the different lines here basically vary different characteristics of the trees in terms of what their roots are like, their stems, their canopy structure, and those kinds of things. The good news about this, again, is that it supports this fundamental concept that we can all believe in, and perhaps in terms of the conversation earlier this afternoon, that we can perhaps talk to the public about and have a real discourse about. The idea that the more mangroves you have, the more effective that you can be. You have to have a certain amount, you have to have a certain amount of mangroves to be effective, and that kind of effect tails off after a certain amount. But do you want your waves to be 1 meter high or half a meter high? I mean, how much effect are you going to get in this system? There are a lot of variables in that. So, you know, my message here, I guess, is how can the science that we know about these things, how can it actually assist coastal communities? And I think one of the important things that it can do, and I didn't actually put this on the slide, is it can manage expectations. And I think as we do try to operationalize some of these concepts, that's actually a very clear message for all of us in doing this. And so these are actually a couple of diagrams from prior to Sandy. It was probably one of the higher profile events, certainly on the Gulf Coast, of this hurricane season, which was Hurricane Isaac. It did actually reach hurricane strength very briefly. And so this is an example of a wave gauge in the Gulf of Mexico off of Orange Beach, Alabama. And this is a water level gauge for Shell Beach, which is in Louisiana. And so what you see here, I just put these in for illustrative effects. These are both in feet, I think. And so what you see is the wave height goes from a normal about 2 feet up to 20 feet. Now this is offshore wave. It's going to be different when it actually hits the beach in Alabama. But this is a pretty big wave. You've got some pretty big stuff going on out there. It's just a Category 1 hurricane, but there's a lot going on out there in the Gulf of Mexico. And you see an increase in water level from 2 to over 10 feet, adjacent to one of those coastal communities on the previous slide. So in these kinds of circumstances, when people are expecting this kind of thing to happen, then what do they want? They want a levee. They want something hard. They might believe that wetlands are important for them, But frankly, that's not going to provide a whole lot of reassurance. And frankly, I think we shouldn't imply that on any of these larger events that wetlands are really going to make a whole lot of difference to them. That there are places, there are circumstances where you really do need a structural protection system. However, I do think that restoring some of our natural environment can make quite a lot of difference to some of those lower magnitude, higher frequency events. And I think we saw this on some of the previous slide. It's not just about the really big storms. It's about the things that happen fairly commonly and the things that don't make the news and the things that actually really interfere with your everyday life. This is not a major hurricane. This is just a windy day along the northern Gulf Coast in a place that's very low-lying. And when the road floods like that, it really affects you day after day after day. And it probably happens every year. It probably happens a handful of times, 10 times a year. It's a real issue for people. You don't evacuate on a nice sunny day 10 times a year. It's something that really affects you and your community and the quality of life. So I do think that just a few final messages here as I'm on my orange slides. What do I think all this means? What does this issue about the ecosystem service of coastal protection really mean for coastal communities? I think one of the most important messages that we have to get across is that big flood events will still do damage, even if we do coastal restoration, and we have to prepare, adapt, and importantly, evacuate from those. Sea level rise, I didn't put anything specifically in on this, but I'm sure you all know that sea level is rising, and so what that means is that the same storm floods you more than it flooded your parents just because the overall water levels are higher by a foot or more, and it progresses over time. There's a little bit of a dynamic in there, but I think this is generally a very good take-home message. But I think that it's this more frequent non-disaster events, if you like, where actions to restore coastal habitats can make more of a difference. And I think that those differences can actually have a real influence on people and really be of great value to them. When the roads flood like this, the school buses don't run to the community that's at the other end of this place. So that means that you're either trying to get your kids to school through this, or your kids are not going to school. And that is a real issue for rural communities. The yards and the parks flood, people are not going out as much, mosquitoes increase, obviously that's a really direct public health issue. Houses need to be elevated, not just to get out of the storm surge, but to get out of regular flooding. That becomes a real issue for the elderly and the disabled. Yeah, my house is 10 foot off the ground. I know what it's like to carry the groceries up there. And, you know, I'm getting older. And you have to face that. Are you going to move, or are you going to put in an elevator? What are you going to do? And how are you going to afford to do that? Gravity sewer systems. Many of these rural communities are not on municipal sewage. Basically, you have a septic tank or you have a little aerator thing, and it flows, or it doesn't flow as the water gets higher. And so there are issues associated with that. I do think then, in terms of the message, I would say that there is an important message here for coastal protection, for the way in which intact, restored barrier islands and wetlands interact with coastal water movements, that the messaging there on that ecosystem service is not about the big events. It's not about Katrina. It's not about Sandy. It's about these moderate events. And I think, although I'm not an economist either, I would say that the lower magnitude effect that happens more frequently over a long period of time can still have average annual value because it happens that much more frequently. And so the cumulative effect of that over time can be quite important. There's also, of course, the additional services provided by the habitats, which give you an additional reason to do it and to provide that protection. And the other important thing is that the natural systems that we have are going to adapt and change over time as sea level rises. They're not just all going to be drowned as sea level rises. Some of them are going to be able to keep their head above the water. But for the system around New Orleans as sea level rises, we're just going to have to raise it and raise it and raise it. And that may not always be possible. I also think that you know, when it comes down to it, there are so many reasons to do this that we don't have to lean too heavily on this ecosystem service of natural protection. In the places where it can make a difference on coastal protection for the kind of common events that I've just described, I think it's also the place where you're going to be able to get lots of other services out of those systems as well, and it's going to be the cumulative value added that all of those things provide to coastal communities that's really going to make a difference. And, you know, when you think about a system that looks, this is not a very good picture, but this is what a deteriorating coastal marsh looks like. And this is what a vibrant, these are both coastal Louisiana pictures. And if you had to choose which kind of environment you wanted to live in, which kind of environment you wanted to raise your kids in and be around, I don't think it would be this one where you can't actually step off that boardwalk or you're going to sink up to your knees. You'd want to be out here in the Wax Lake Delta at the mouth of the Mississippi River, where the Mississippi River still builds land, and we have a very, very productive ecosystem that can also provide some coastal protection. That's all I've got for today. Thanks very much. I'm a few minutes over, I'm sorry. Oh, I'm sitting down now.